Hey everyone, welcome Azure Cosmos DB Live TV. I'm Mark Brown, your host. Welcome. Got with me a special guest, Subhasish Ghosh. How are you?
Yeah, hi Mark. Good afternoon. How are you doing? I'm
I'm
doing
doing
good. Thank
well.
you.
So Suba is a cloud solution architect. I got that right? That's it.
Yes.
Cloud solution architect for Microsoft, and he's been working with some of our biggest accounts for a long time, and has developed some really cool stuff that we want to show you. This is something we posted a blog post about not too long ago, and I wanted to bring him on because, frankly, kind of the stuff he's developed, I think, is really cool, and the fact that this is content and knowledge that he's developed working with some of our biggest customers, I think is even more impactful and even more important. Why I want people to see and learn from what Suba here has done. So welcome. Thanks again for coming on the show. It's really great to have you. We had a guy that you and I both know, Abhinav Ramesh, who works on our PM team. And he came on, gosh, it was probably over a year ago
Yeah.
to talk about the Java SDK we have and its ability to provide these client diagnostics, which are incredibly useful for doing some really amazing things to troubleshoot stuff. And but he only touched the surface, right? The thing we missed was like, how can you use these things? And that's what you're here to do for us
Yeah.
this week, right? So you're going to talk about these things. So hey, I'll just leave it to you. Just walk us through what we're going to see today.
Yeah. You're absolutely correct, Mark. So diagnostics, in the Java SDK specifically, is very powerful. It lets you kind of gain knowledge not into just when you fire a CRUD operation as to what exactly is going on under the hood, but if you're especially running production applications, like for example, I focus on a lot of tier zero, we call it mission critical line of business applications. So whether you are application is working perfectly right in terms of scalability, maintainability, especially in terms of performance, kind of, and then also deep dive kind of diagnosing into what's exactly going on under the hood. And then post that, if things are not going well at times, you have certain, what we're going to talk about, latency scenarios, throttling scenarios. Precisely knowing what's going on is what exactly is or you obtain from client diagnostics, right? So before we kind of jump into code and see some examples, I wanted to cover one key aspect or a question which I often get asked. So when I'm working with dev teams or architects, even platform architects, or specifically with the SRE teams of tier zero, they say, you know what, this sounds all good, but the what and why, like when I fire a CRUD, like why is knowing diagnostics, going to help me? Or what is the diagnostics all about, right? So in one line, how I usually, kind of explain to them is when you fire a CRUD from the SDK, right? Basically, a few things happen behind the scenes, and what we call the request is traversing through the transport layers. So we call these transport layer events. So knowing holistically how that particular transaction is working and having a knowledge on those transport layer events is what diagnostic gives you at a very, very summarized high level version. And once you deep dive on those transport layer events specifically to your use case, if you have a high latency scenario for a P99 or a P97, you're talking about very high volume, very low burst scenarios, specifically for e-com, and retail scenarios,
Yep.
where time is of essence. I mean, you're
Yes.
talking about 5 millisecond, a little bit, you're talking about a $1 billion loss, right, in revenues, those kind of scenarios, those transport layer events that you can extract those knowledge from and leverage your knowledge of in-depth troubleshooting, and of course leverage us to kind of work with you. So it's a combination of both. It's like same two sides of the same coin which diagnostic gives you. So Mark, what about
Yeah, I mean, you make great points there, and you point out like you're working with these even like e-commerce scenarios where like milliseconds equals real big dollars, right? Especially at super high
correct,
volume. But even at small scales, the information you can get out of here is actually quite helpful because
correct,
even at those scales, there are sometimes things that need to get troubleshooted, and it's hard. Like where do I look, right? And what I found
correct,
using these is these can really help you zero in on where the issues lie, right? And where you need
Correct.
to go and look with this. And that's what's so powerful about them. I mean, I'll be the first to say the JSON output from that client diagnostics is rather
Correct.
intimidating at first because there's just so much
Yes.
stuff in there. And that was, I think, part of the value of what you were doing and what you're showing us is how do you read this thing and then use it
Correct.
to troubleshoot an issue. So yeah.
Absolutely, absolutely. So let's kind of jump into some code and kind of see exactly how it looks like. So that's the one slide only that I have. So let's say if I open up Eclipse here and kind of run through some code, it would be good to understand. So what I have here is basically Java SDK 4. I'm using the program, and basically I'm using the 4.40 Maven jar as well. I just wanted to kind of showcase this as well on the portal side of things. So we do maintain our change log history, for the Azure SDK for Java. So I'm using the 4.40, and if you're a developer, you can come to this page and check out the different feature releases per release as well. The latest unreleased is the 4.41. It's important because we always recommend folks to use the latest Java SDK. So 4.40. So basically in this program, right, what I'm doing is we are creating a database, a container, then a couple of items, and then we kind of iterate through it. So very important point to note, right, is that for a database, a container, item, and query responses, right, I have a diagnostics property. And as you mentioned, right, the diagnostics are returned as a large, string. So for example, here, let's say I'll keep it very simple. So let's say only 2 documents if I kind of execute. So let's kind of check this output, how it looks like, and then we're gonna see it in action as well. So all of these STD outs that you see, and then you have the database diagnostics. For example, here the create database diagnostics, you see the create container. So let's pick up the create item diagnostics. Now this is a complex long string, not so good to kind of read through.
Yeah.
Right.
Yeah,
So
not the user experience is not that awesome. Right.
yeah, it's definitely not that awesome. So what we request and what we usually, so when I work with dev teams, is you simply copy it, you go to your browser and open up any of your JSON formatters out there. A couple of them good ones are out there. The easiest one I personally prefer using is JSON formatter, this one. So all you do is you paste this, you kind of go and remove the prefix content a little bit, half a line. So you see the content kind of comes up like this. So if I kind of increase the size, right, you see it is pretty much easy to read and a well indented kind of a JSON output. Now this is quite a lot of data in here.
It is a lot. And I don't think you need. I mean, I don't know. Are you going to talk about, I guess, some of the big pieces in here? I guess for people to help navigate. Okay.
Yes. So what I would suggest is, maybe definitely refer to the blog post which we are kind of asking folks to definitely accompany as a read for this, but definitely where more details are there. But just as a very high level, right? For example, for this create operation, right? For very important is your user agent. It's basically the name of the client instance that is running on your machine, right? Request latency millisecond. This is very, very vital. I mean, this is practically one of the most important things which folks look at, right? It's how long your operation took. That's when we see all the diagnostics for a create operation. Response statistics links is basically the store result is the bulk of the JSON content here. Store physical address, again, very, very, very vital, because the RNTBD, which is the TCP layer stack, right? It has a lot of information around which precise replica we are going to. So here, P basically means a primary, or S means a secondary replica we are hitting. So all of this information, as you can see, you can go down from the Cosmos DB account to the service to the partition. That means the physical partition on which the data resides, right? And specific even to the replica.
Yeah,
so
if people weren't aware, like that's you basically just described the address to our backend storage, right? And so for people that aren't familiar with how Cosmos works, the way our backend storage works is we have physical partitions where your data actually sits, and then we have 4 replicas for each of them. Correct. And so what you see there is a full path to the actual physical replica where that operation happened, whether it's a write or a read within there. So that's what he's showing within
Correct.
there.
That's the FQDN to the exact replica
location
which
for that
is
data.
US.
Yep.
Yes. And very related to that is the partition key range ID, because again, it's very important. It kind of identifies precisely the physical partition, as you mentioned, to which this request was sent, where this create went.
Yep.
And again, very important for this. And for example, here, again, the bulk of it is in the transport. This is what I was talking about, the transport layer. So I spend a lot of time working with, let's say, our engineering teams on the customer side, or SRE teams, or cloud support engineering teams, or maybe individually with the dev teams, and we're doing a lot of stress tests with them on the transport request timeline. So here you see a subdivision in which I see a created event. It's basically, we are creating the different things, the Java SDK is appending headers here. We are looking into the cache to read the master partition table, how to kind of map the logical to the physical address, and so on. We still haven't sent anything. Queued basically means that, the client request is understood. We are going to send it. Channel acquisition, very, very vital. Some milliseconds you see spent here. Basically, I'm acquiring a channel. It means basically a socket connection to the endpoint, right?
That looks like a cold start you just had there. Is that what that is in that latency for the duration there?
Yes, exactly.
Okay.
So basically, yeah. So that you see there are some milliseconds latency there. That means basically, I'm waiting to, or the service is waiting to acquire that particular channel, right?
Right.
And of course, again, we don't have one channel here. It's multi service. So we have multiple channels that we create to that particular endpoint, right? And even on a single channel, you have multiple requests which are going on. So it's highly kind of optimized. Pipeline is basically means that post, the channel has been put, but we still have not sent it across. We now put your request on that particular wire to send it across. So one important thing that we often kind of encounter is if there is an issue and you deep dive, you need to understand that the created, queued channel acquisition started and pipeline are still on the client side. We still have not sent anything across the wire. The transit time is the time when we have kind of sent data across the wire. The request, that means, has gone through the channel. It is hit, and it is supposed to do whatever it was supposed to do. And assuming that there were no intermittent connectivity issues or drops, right? It has now come back and it has performed a round trip, right? Then we kind of clean it up. We add some, we strip off the headers, and then we kind of give it to you, right, in a correct format. So that's what decode received and the completed kind of means. As you see, it's very low latency, right? So for this,
right.
So now moving on, right, precisely how to diagnose and troubleshoot. So let's look at something precisely, and then we can kind of go back and understand where this is important, to how when I work with customers, we kind of try and troubleshoot. So let's say in this code, as you can see, there were two documents I were creating, and basically if I go back and see the portal here, all of my kind of collections, in this particular collection which I'm working on, FAM DB CRUD, is only 400 manual throughput RU. So it's pretty low, right? I mean, in terms. So now let's say if I kind of increase this to, instead of 2, let's say I make, so that basically 7 zeros is 10 million. So if I kind of make 10 million documents, and basically, let's say I run this same code, right? You will see eternity, all of these items are getting created. So you will see eventually we reach to a stage where, some of the create operations, precisely for this particular use case, you will see them kind of, failing to get created, or rather getting throttled. So you would see a situation like where when I open up, let's say the portal for this particular operation, I want to just show this in real life. So I ran 46,000 requests here, but you see 2.27, the 429s, right? I've got throttled. Now, one very important information here to understand is how do you kind of, so do you see to the portal, how do you kind of capture the associated diagnostics, right? And then kind of deep dive into understanding what exactly caused the 429. That is what the essence of really deep diving into diagnostics is all about. So, for example, if I go back to the portal, let's say I go back to, this, and kind of let me open up. So I'll browse through. So are you exceeded? So let's say this particular, JSON output was generated for one of our operations. Now, once you see and you go through, and so again, you're scanning through this particular thing, right? So instead of the first one, so if I kind of go back to the one where successfully we got created, right? You will see in this particular status code, we have 201. That means the create operation did succeed it went through and we kind of had a success. But on the other hand, for the one which failed, right, for the throttled ones, you will gradually see a status code here 429, which is very important to understand. Now, one very, very important point here, which I kind of deep dive with the app teams to explain, and of course, they understand once we deep dive with them, is 429 technically is a status code, but 429 is technically not an error. 429 is a rate limiting signal thrown by the service to you. So in medicine, it's very easy to explain. So people who suffer from jaundice is technically not a disease. When you have issues with your liver or with some problems, right, jaundice is a resultant output. So 429 by the service is exactly like that. What is very important to know, and that is where you need to deep dive, and I work with teams, right, is the sub-status code. Now here I want to spend a little bit of time on this. So every status code on Cosmos, and we give the service provides you, right, you have an associated sub-status code. So for example, let's say, now how do you precisely know that for this particular throttling, whatever RU consumption I've given, like 400, is pretty low, and hence my requests are failing through. Very important, and you can easily find it out. And if you're supremely confident, you will find that in the sub-status code, it's coming 3200. So, and how would you kind of know this? So if I open this up a little large, the perfect place to go to look for this is the retry context, which gives you the status and the sub-status code. That's the first point you should look after you have figured out that there's something wrong. Either I'm facing high latency, or my requests are not going through, I'm unable to read. It could be anything. So once you have seen that, the perfect place to go is to look for the retry context in the status and the sub-status code, is where you see the sub-status code. Now, why is this very important? So 3200, and if I go back to that associated blog post, which we have shared and do share with dev teams as well, where we have kind of shared the different options of the sub-status code listed under a certain status code. I've taken, for example, 429 to show here. So as you see 3200, if you have this knowledge, this basically in one word means, are you budget exceeded? What that means if I have a container to which I have allocated manual throughput, at a given instant of time, whatever RU per sec is the max allowed optimal capacity, I have exceeded that limit. Hence, the container, and to ensure the stability of the service, is rate limited me. So there are multiple ways you can take here. It could be like you kind of increase it manually, or you go to auto scale, or you kind of lower your rate limit. Instead of 10 million, maybe you ingest batches, or you work with us and maybe we could help you kind of bulk ingest and all of that, right? Why is this also again very important? Let's say instead of this particular operation, I was now doing a read operation. So let's say in the same JSON, I'll basically want to upload a stored proc, let's say concurrency error. I want to show this. So let's say for this particular operation, again, this is captured from one of our real life examples where we worked with the customer. But so we were getting 429s. But hang on, was this precisely because we were facing rate limiting on this service because of the presence of low amount of RUs? Technically, the answer was not. So how did we figure that out? Because the sub-status code was different. It was 3084. So when we initially got in touch with the team was, I have increased 1 million RUs to 4 million RUs, but still I'm getting loads of 429s. That was the precise question asked, right? So when we got involved, first thing that we said, hang on, have you kind of activated diagnostics?
Yeah,
so once
the first thing we say, it's not just you, it's the first thing we say too.
Exactly, right? So this gave us the reason that this is not 3200. So even if I increase 4 million to 10 million here, I will still get a 3084 here.
Yep.
So 3084 means basically for us, when you basically execute stored proc, right, on Cosmos DB, the NoSQL API, it has a concurrency limit. So you are basically reaching that particular limit. Hence, your service is basically throwing you a 429 with a 3084. So this knowledge then becomes very vital doing creates and for reads, and specifically if you're doing bulk operations, right? So this is what something is very important.
Yep, that's very cool. For viewers, so when it's showing the retries there, that is inclusive of that's basically the SDK retries before it comes back, right? So because
Correct.
we'll retry up to, what is it, 10 times, I think, by default?
9 times.
Is it 9? That's right, 9 times. Okay, so
Correct.
you have the first one and then 9 more to make 10
Nine
total,
more times.
10 total tries in there.
Correct.
So in this one here, you're seeing it retried 4 times.
Correct.
And then, yeah. Oh, well, yeah, tried 4 times, 3 retries in here.
Correct.
Yeah.
So another very important point is usually what we kind of work with, and the core information that you get out of it is this particular retry latency that you are facing, right? Usually correlates to different client side issues as well. Often, for example, here then there's nothing wrong with the service per se, but it's basically we need to kind of work with the client team to ensure that the concurrency limit on the stored proc side is not exceeded. So this is very important, very vital, because this kind of helps us troubleshoot and go one step deeper. Correct. This is like very vital. And here another also very important thing I wanted to mention is right now, if we go up in the 4.40, we have kind of added this particular feature, retry after in millisecond. It was not there in the earlier 4.39. This is very vital. This precisely gives you the time if you want to fix after how long you want the service itself to retry.
We expose that in the Cosmos exception object, though, don't we?
We do that, yeah, but you then need to extract it kind of and then study.
You can then put that in your own retry logic then to just back it off and then try after that period of time in there. So you're saying it's new in the diagnostic string?
Yeah, it's from 4.40 it got added. It was not there in 4.39. But one important thing, why is this important, Mark? I'll kind of explain a little context is I have worked with 90% of teams who kind of pass this data and then study it only when they have issues. But I have worked with teams where this information is so vital, precisely for tier 0 during that Cyber Mondays and Fridays. What we do is we capture this input as an if condition. So if, let's say, 600 millisecond is my read latency maxed out for a very high read intensive, where I'm doing point reads, if I cross the P99 latency for that 600, automatically this code gets fired. So what we do is we capture this object, we then pass it, and basically it is sent to either Splunk or maybe an equivalent tool, a dashboard to study. So there, this information becomes very vital, because if some of the fields are missing previously, like as we worked with the SDK teams, right, then we have to go back in code and object and define from the Cosmos client options, right?
This was a question I was just thinking of asking you, actually. A good segue. Like, this is kind of dense to look at, and just studying it like as a human, yeah, that's okay. But in real production life scenarios, there's lots of these things flying every second across multiple SDK instances, maybe multiple workloads. Impossible to process these things as a human. With the customers you work with, do they monitor these things or sample them and then fire triggers based upon values that they're seeing in there, or are they using other metrics like through Azure Monitor or some other way to surface these things, measuring things like latency or retries or whatever it is, and then using that to trigger their SDKs to go and sample or capture some of this information and then funnel it into like a Splunk or something where they can then maybe take a deeper look, but do it at a scalable way?
Yeah. So precisely the answer would be, Mark, it's a combination of both. Yeah. Like, for example, some of the tier 0 teams, they have a combination which we are pulling from Azure Log Analytics, processing it, and basically trying to get some bulk information out. But precisely for, let's say, an e-com portal, without taking any reference name, cart and checkout, and then the supply chain management, couple of very important tier 0, let's say, microservice applications, the bulk of the P99 and then the actual latency, like numbers, whatever we have threshold, like for example, we have 4 important threshold: read intensive, write intensive, stored procs, and basically if you are executing cross-partition queries, basically what's the time limit, right? If we are exceeding or near about going to that time, all of the core information are all pulled out from Cosmos Diagnostics, because that level of information, which for example, right now I showed, let's say I'm having a additional 4 millisecond of latency on an application. So let's say I'm doing a patch. It's supposed to be 1.1. But on 10 million patch, I'm moving from 1.1 to 3.2. This is practically impossible to tell from data that we get from Azure Monitor or Portal or Log Analytics.
Yeah, because it's like that 5-minute roll-up data. It's aggregated. It's not hot data. It's
not hot data, right? So, and here I'm talking about 1.1 going to 3.2. So if you minus 3.2 from 1.1, this is milliseconds, right? That information, if you fire Cosmos Diagnostics, precisely in the screen right now, what you are seeing, if you get that in the queued, something as basically queued up but not executing, and this is my exact 2 milliseconds, you can precisely immediately get into contact with Microsoft and tell, you know what, nothing's wrong with my client side. Maybe you should look at, kind of decongesting that particular queue.
Yeah, you know what? But 9 times out of 10, what happens is people call us and they say, "Hey, it's your service it's your fault," and then we ask them to turn this on, and then we see right there, it's like, oh, yeah, you're basically starting a new connection every single time, or there's something going on where it's just taking forever to say deserialize or to serialize your data. Something's happening somewhere else. So, so I was going to ask, like, so we've talked about the rate limiting one. Could we spend a few minutes talking about the second one that you wrote about? Yeah, this one here. I see. So I was just a lot.
So I was just going to that because that is a bulk of the work that we do. So so basically, we often see scenarios where there is high latency writes accompanied with a high CPU, and invariably, if I go up to the table which we have mentioned, invariably for these bulk writes, we see eventually a time when some writes are timed out with a 408. Now it's a combination of all three, and they're pretty complex. So if they are for a tier 0, the only way to look at it is in the Cosmos Diagnostics, right? And which is the core bulk of it is the serialization diagnostics list, where they kind of give you this serialization number. Now, this I want to a little bit explain. So what happens is when you create a POJO object, right? I mean, we need to send it across the wire. So we need to kind of deserialize it, send it the bytes across the wire. Then again, when the answer comes back, serialize it and throw it back to you, right? So 2 things which I have always seen, folks do, and which is a direct correlation to, I'll come to the system CPU load, is if the document size is not correctly set. We have worked with people who have in MBs. We have kind of still worked with 50 KBs, which is very high. 1 to 5 is perfect. Another aspect of it is, though they have document sizes, like exactly this current week, I had like meeting with 2 different teams where the document depth was 7 layers deep.
That's right.
7. Yeah. So it's completely nested. So we explained to them, so that means basically you are burning nothing but CPU cycles, denesting that, because your CPU needs to burn to kind of reach to that 7th layer depth. So Microsoft's strong recommendation is not to go to 2 would be best, 3 is the max. And we have seen this typically what happens if you do not follow these 2. That means you are working with larger documents and you have high nests. So on a large document, your system CPU load that is specifically in this particular document, if I kind of scale this down, where you have the data, then the serialization, and then eventually in the system information, you will find the system CPU load, which technically we give you, it's read as a 5-second, for a 30-second window. It will go up to 95s, and the moment it goes to 99, it gets choked. So a bulk of writes will go through, then it will be followed by a bulk of writes, which will fail with a 4.
And that's what you see is like, hey, some of them work, and then it just stops, right?
And the most common thing which I've come to hear is maybe something on your server side has gone wrong, or maybe one of the replicas.
Yeah, it's always that, right? Yeah, exactly. I just had a question on Stack Overflow, I think a week or 2 ago, and the exact same thing. The initial complaint was, hey, something wrong with your service here. And I said, yeah, that sub status code actually means that there's probably something going on client side. And I never heard back, which means that was probably the issue.
Correct. Correct. So if there is a high latency writes happening accompanying with a high CPU and the status code is 408, closing, kind of being very confident, I always point out to folks that, hang on, can we take a look at your document size and document depth? 9 out of 10 times, this is what solves the issue. So this is something which, if you are a developer watching this, or an SRE team watching this, and you have scenarios like this in 408s in high latency writes, please do go and take a look at your system CPU load, and specifically the serialization diagnostics contest. It will give you the time in milliseconds.
Yeah.
If this is in 3-digit number, something is wrong.
Yeah. By the way, another thing to point out too is even when it's not client side, really large documents grow at a not quite linear rate. It's a little quicker than linear in terms of RU costs there. So not only are you paying it in latency to push that amount of data over the wire for every single request, and by the way, every time it comes back as well.
Correct.
If you're asking for the response on write, you're taking it twice. But also the cost, the CPU, the RU to process the request is also going to grow faster than the size of the document as you get in there. So always best practice, keep them small, right? That's going to be a faster request and cheaper, both on the client and on the server side. So yeah. Great stuff. Yeah. Anything else you want to show us, or are we done? What do you say?
So do we have a little bit of time, Mark?
Just to cover a bit more. You got one more thing?
Yes. So I wanted to cover a combination of these two particular scenarios. Again, if someone's working on high volume request handling on mission critical applications, possibly this is something which they really should look at. So this we kind of is basically looking at is if you have a breach of a 10 millisecond read latency in a P99, that means a huge volume of requests come to you and it's a burst scenario. What happens, like I don't have any error code precisely here, but you find that the latency is very high. Same scenario, that is I have a breach of a 15 millisecond latency in a P99, but instead of basically point reads, I'm doing basically in partition queries. And very important to know here, these scenarios are not that the point reads are not working correctly. They're already highly optimized. Developers know their stuff. Again, in partition queries means we have checked the partitions, everything, no skew in data, yet you are facing a little bit of latency. So then very important to or note or to cover here is in such scenarios, there is basically a client config settings in the client configs, which basically points to a connection config settings, which basically has a couple of parameter values which are tunable, and you fix them at the SDK at the code level, which are pretty important in the sense, they're very important in the sense it kind of defines your connectivity to, and also how those kind of work or interpret with the RNTBD layer. That's why you see they start with the RNTBD. So I'll quickly just run through the CTO is basically a connection timeout duration of the TCP stack. So basically what it means is 5 seconds by default value. That means if I have any connectivity issues, please retry, don't wait for too long. So it's here set to 5 seconds, but for very high intensity, tier 0, high volume, low burst, you should customize it as low as 0.5 to 0.6 seconds. It works perfectly fine. NRTO means the network request timeout, which is pretty standard. So we have it again as 5 seconds, but you can definitely don't want to wait for 5 seconds. You can choose to kind of, override this particular value. ICTU and IETU are very, very important. So basically this is ICTU is the idle connection timeout, which means if I have a channel or a socket, right, connected to a particular endpoint, and there's nothing going on that channel, I know that means I'm not sending a volume of requests on that. Do you want to tell the service that I still want to keep the channel or socket alive? Now, or maybe do I terminate it and kind of, I then can set the value as 0. IETU, again, very, very important. This is basically, I have a specific like endpoint, right? But endpoint to what? It's basically connected to a replica, right? So in such a case where, I'm not connected to it, but do I still need to keep this connectivity to that endpoint, or do I kill that connectivity? Usually for large volume, we kind of, recommend keeping this maybe high as 1 hour, 2 hours. We can even keep it as high as a 3-hour, period. The reason is good. Why? Because during a downtime, if your request is low, so next time when you fire, right, the SDK again needs to reestablish connection, basically do the SSL handshake. So these are little bit of optimizations, definitely save you milliseconds, a couple of nanoseconds add up to milliseconds, right? And then MCPE is basically the max channels, I think, per endpoint, which is the default number is 350, but you can kind of configure it with the SDK. And then how many requests do you want to put on the channel? So these are some of the things which we strongly recommend. And as we have explained it, of course.
That endpoint is 2 replica too, right?
Yes, yes,
Okay,
yes, yes.
so the bigger your container, more throughput and more replicas or more partitions you have. Remember that's 4x for each because you got 4
Correct.
replicas in there. The bigger your collection, the more you're going to have. So it's 130 per replica.
Exactly.
Yeah. If you got
Exactly.
if you're
Exactly.
less than 50K, that's one physical partition. So 130 times 4 basically is
Correct.
going to be how many of
Correct.
those
So we
buckets
have
you have.
kind of explained the same thing in an in partition. So if you look at a real life example, so let's have 100 partitions. And by the way, when we work with real customers, if you have around 50 to 100 GB of data, it's maybe not a matter. But once you go to the 10 terabyte, 5 terabyte limit, like I work with customers who have actually 4,000 like partitions, physical partitions. So this matters
Right.
a lot. So here, 100 multiplied by 400 replicas with max connections. So you define the number of connections to be created. As you can see right in the code, all you need to do is basically, set these variations. You can fix it 5, 5, 3s to 130, and then basically define, how you kind of do it in the SDK. But this massively solves problems, specifically if you have high volume, and in partition, you're finding high kind of volume, basically a little bit of high latency, both in point read and in partition. So again, where do you see this? Where do you deep dive into this? If there are any issues in the transport layer, is in the diagnostics itself. So this information again is very vital if you're running, what do you call, tier 0 applications.
Yep. Yeah, this is great. I mean, shaving, you're definitely getting into the guts of our transport layer when you get into this stuff. But some cases you have to when
Yes.
those milliseconds matter, and that's money to you or performance or both in there. It's important to know. And look at even if you're at a small scale, it still helps to understand what these things are because they can help you even try troubleshoot issues just to know is it you or is it the service where the issue is, right?
Yes.
Or maybe it's the network in between, right? It'll help you at least eliminate things that is not the source of your issue, so that if you do have to raise a support ticket, you've got everything you need in hand to go and say, here's what I'm seeing. I know it's not
Agree.
this or this. Here's the diagnostics. Let's figure this out. So yeah, this is great. I loved it when Abhinav was on and explained this stuff. I mean, it's just amazing how much information we provide that's going on in there, and then just to see, this is the valuable part, right? Okay, how do I use this stuff?
Correct.
This is what's super valuable, and I think users are going to love this. So
Yeah. So Mark, how I kind of put it to developers who are onboarding to Cosmos, because I do work with a lot of junior developers who are maybe coming from other NoSQL services onto Cosmos. I tell them, why don't you use, even if there's not troubleshooting right now that you're working on, but take this JSON output and use it as your own study material to get deeper into the service. Because if you understand even not 100%, but 50% of what is going on under the hood, specifically in the transport layer events, I mean, you already know, so you'll be solving half of the problems which you create while coding yourself. You wouldn't require a support ticket.
right, you can use this data to see, like, are my queries like fanning out, right? Like you can use this if I was like an SRE or otherwise monitoring these sorts of things, and I was getting doing some load testing and going into production. You hope that the ops guys are doing stuff like this, or your SREs are doing stuff like this. But even
Yes.
if it's just a developer, you can use this information to essentially
Correct.
analyze your design. Like, is this thing going to scale particularly?
Agree.
Right? So there's lots of uses, lots of information. It doesn't have to be if you're just troubleshooting something. It can actually give you insights into the design and performance of your application. So
Absolutely. Absolutely.
well, this is great. Subha, thanks for coming on. I know it's very late for you. So, hey, folks, by the way, this is at 1 p.m. Pacific. He's live coming from India right now. So it is, I want to say, just after 1 a.m. It's after 2 a.m. I always get
It's
I know
3
it's
a.m.
12 and a
actually.
half, right? But I always get which side of 12 it is. So it's, yeah, right. So 2 o'clock after 2. So I appreciate you coming on. This is great. Really happy with seeing this, and thank you again for contributing. I think our cloud solution architects are just brilliant people, and what I love is and I've had them also come and do other blog posts and contribute content because frankly they work with our customers, and the stuff
Correct.
they are learning is real world. usage of our service, and that's valuable to other users who are looking to use Cosmos. They can get that learning and that experience out of that. So thank you once again. I really do appreciate all of you've done in writing this blog post and in coming on the show and talking about everything you've learned here. So thank you again.
Thank you, Mark. Most welcome. I hope this will be useful. Thank you.
Great. Thank you. Hey, folks, thank you for joining us. Good having you this week. We'll be back soon. So stay tuned. And before I go, make sure you come and check out our monthly Cosmos DB user group, aka ms/Cosmos DB user group. Come and join our meetup. We're running meetups pretty much every month. This is episode, I think, 70. So that means we have 69 other episodes for you to go and binge watch. So come check us out at aka ms/Cosmos DB live TV. So that's it for us this week. Thank you, everyone. We'll see you all next time.
Take care then.